Okay, so I decided instead of using my iPad, we would do logarithms just using the board like a traditional lesson. Because there's going to be a lot of different rules and some things that we need to compare while we're solving logarithmic equations. So I'd like to have the rules here and then we'll solve on this side. Okay, so let's start off maybe with why logarithms are important, and maybe one of the more important things honestly we'll do in this course. So let's say that you're working with anything in chemistry or microbiology where you have an exponential function where you need to solve for the variable that is in an exponent. Okay, so basic algebra rules say that if you're going to solve for a variable, you need to do the inverse of what it's at or what you're doing with that variable. So if your variable is in the exponent, the inverse of exponential is logarithmic functions. So we're going to use logarithms to solve for the variables that are in exponents and vice versa. All right, so first things first, this is our function notation for our logarithm. So we have log with a base a, and then we're taking the logarithm of x. And again, this is the inverse of exponential. And then another thing, now we're not really going to have to graph this, but if you can graph, you should be able to graph exponential. If you just do that reflection over that line y equals x, or understand how inverses work, then you should be able to see the graph of a logarithm. And you always have your calculator if need be. Okay, other thing property-wise we need to know is the domain. So what we're taking the logarithm of, or x, has to be greater than 0. So it cannot be 0 and it cannot be negative. All right, so since the main reason I've mentioned that we're going to use logarithms is to solve for exponential functions, let's talk about maybe the main thing that we're going to do, which is how these two relate to each other. So maybe let's just do a basic how you convert from exponential to logarithmic. So let's say we've got an exponential function, y equals, and then a to the x. All right, so this is exponential because our variable x is in the exponent. If then I wanted to convert this to logarithms, okay, so if we're converting down to logarithms, what's going to happen is this a, or the base of the exponential, is now the base of our logarithm. So log sub a. So the base of your exponential becomes the base of your logarithm. Then what you're taking the logarithm of is going to be what's on the other side of the equal sign. So in this case, y. And that is going to be equivalent to that exponent, x. Okay, so again, we're solving for the exponent when we convert to logarithms. Okay, the whole point of what we're doing. Now, I've got kind of a nice little trick that I show to my students to help remember this conversion, because sometimes this straight conversion or just remembering how it flows is not the most intuitive. So I had another teacher show me years ago what's something called the swirl method. So when you do the swirl method, what you're going to do is you're always going to start at the base. So if I'm converting down here, I start at the base and you swirl towards the equal sign. So swirl to equal sign. Okay? So start at the base, we're going to draw the literal swirl around this function and back to the exponent. So what happens is then when you make your conversion, again, you start at the base, so log base, and as you go towards the equal sign, you pick up what's on the other side, in this case y, and then you come back around to that exponent x. So that's how I always remember it. Again, if you can do this, just make sure you're swirling, starting at the base, swirl towards the equal sign, and kind of move along this way as you go. And it works both directions. So if we're at logarithm, we have log base a. If we start at the base, we swirl towards the equal sign and back around to what we're taking the logarithm of. We've got base a, around, picking up this x, is equal to y. Okay, so that's how we're going to convert between logarithmic and exponential. That's, in my opinion, the easiest way to do it. Okay, some other rules that you'll need to know as far as for solving and for the homework. There's a property, so since they are inverses, if you had, let's say you have logarithm, so log base a, okay, if you're taking the logarithm of an exponential function, so you have log base a, and then what you're taking the logarithm of has base a, and then we'll say a to the x since it's logarithmic function, what happens is these two bases essentially cancel out each other. So since they cancel out, we are left with just the exponent. So maybe the way you'll see this in homework is if you can convert something to exponential form that has the same base as what the logarithm base is, then they cancel each other out down to leaving us just the exponent. And it works the same way too if we have an exponential function with a logarithm in the exponent. If they both have the same base, so this is base a of the exponential, in the exponent is log base a, and then we'll say of x, these a bases cancel each other out, leaving us with just what we're taking the logarithm of. Then the last kind of property we need to talk about before we start adding different rules is what's called change of base. Make sure I got enough room here, looks like it. Okay, so this is called change of base. Now, this is useful mainly if you are trying to evaluate it where you want a common base. Okay, so I guess what I mean by that is if you've got log base a of x, what you can do is you can convert that to a ratio of logarithms that have the same base, where what you're taking the logarithm of is on top and the base of the logarithm is on bottom. Now again, this is mostly useful for if you're trying to put this in the calculator, and I'll kind of show it different ways. Sometimes it wants the answers in change of base form, but we'll talk about that more whenever we get to actually solving equations. So these are our main properties of logarithms we need to understand. Again, we're going to be using logarithms and these properties to solve for exponential and logarithmic functions. The next video I'm going to make will then now show maybe some more properties of common logs and what's called natural logs.